All right. So so far, our input and output was via keyboard, and input was via keyboard. We could put in numbers, like in Pruter, of course, we put in numbers by default, and also we could print the result of a calculation that is there coming in the terminal. So the computer is doing input and output, but it is default. Keyboard input is default, and terminal output is also default. But we can write on a file. So let's say we have lots of data. So you don't know to type. In fact, you can't enter it on keyboard. I mean, let's say 2,000 numbers or 2 million numbers. That is impossible to put on a keyboard. So you put that in a file, and from the file we load in the computer, and Python reads from there. Okay. So Python has this feature to read from a hard disk. So file, I meant there's something in the hard disk which is permanent storage. So yeah, so we can either write to a hard disk or read from a hard disk, and that is what will be covered today. Please remember the storage in the variables in RAM are temporary, so they disappear when computer is powered off, or there's in fact if there's some problem in the computer, it shuts down, then you lose the data. Okay. Also, sometimes program may just malfunction. Computer doesn't power off, but your Python program may crash. So then also you lose the data. So that's why in Pruter also you should save often. Okay. Okay, now let's see. So we need to understand what a file is. So as I said, we can read to a file or write to a file. So in Python, we'll see a statement of this sort: f equal to open file name data.txt, comma. What are you going to do with that thing? So this is an argument. Okay. So operation. So it's a write operation. I'm going to write to this file from RAM to hard disk. Okay. So this is a file name, and this is the operation which I'm going to do on that particular file. Now please note that this f is also called a file. Okay. So this is called file, and this is also called a file. But f is different than the name data.txt. Okay. F is more than data.txt. F is an object of Python, and which for this object data.txt is only a name. Okay. Yeah, you need to differentiate this. So data.txt is not same as f. So f will contain file size, file type. So it has lots of information which it needs for read, write, and things like that. You don't need to know much more than that, but the contrast must be clear. And they're similar to C. In C also, we create an object by similar function. Okay, now these are called access modes, okay, operations which you do with files. So many operations are possible with files. We can read. So you need to give argument within double quotes R, or W for write, A for append. What is append? Append is already there are some contents in the file. I add to that content at the end. So like append for a list, no, we had it. Similarly, you can append to a file. R plus is for read write. Okay, and these four things are for text files. Text is like ABCD01, so or your Word file or fiction file. You know, these are all called text files. So typically it is stored as ASCII. There could be other formats, but ASCII, you can think of ASCII as a format which we covered in the class. Now we can also store them, our numbers in binary files. Okay. Now I will tell you the difference why we need binary. So especially for numbers, which we do it for this, do it in this course, we need to store large arrays in a binary format. Need means okay, is preferable to store. I mean, you can also store in text file. Okay. The reason why it is important to save in binary format is the following. So imagine there's a floating point number. Okay, a floating point number, which has lots of digits. So it could be 1.23456 in decimal. Okay. Now this number is stored inside the computer as a binary, right? Zeros and ones. Okay, in that format I told you, like there is a certain some certain bits for mantissa, some bits for exponent, and things like that. Okay. Now, so when you try to write in text, the binary will be first converted to ASCII. So it is a binary format. Now I need to convert to decimal first, and decimal it can write in either 1.2345, or it can also write in terms of exponential format. But this conversion, of course, will take time in a computer. But it's not all that expensive. This conversion is not very expensive. But what is a problem is during the conversion, the number could be having, well, I mean, there could be 15 significant digits. Okay, so 1.2345679, then again 123. Now we don't want to store all 15 bits, 15 digits. It will take too much memory, so we truncate it. Okay, so we'll truncate it, and so there is a truncation error typically when you store the binary numbers in decimal format. Okay. So first is conversion error, then truncation, because we don't want to store all the bits. That's one problem. Second is size. So binary number we'll just store as, for float we'll store as 8 bytes. Okay. Now suppose I need to write that as a decimal number with 10 digits. So which one will take more memory? So let me see. I want to get people to put in chat box 10 digits of number with a decimal. So it is 1.234566789. Okay. So we have 1 to 9 and 1 decimal. How many bytes is going to take in ASCII format? Look, I told this before that every character requires 1 byte. So I have 10 characters, 10 digits is each digit is 1 character, and a decimal is also a character. So it requires 11 bytes. Okay, so that is what we need, 11 bytes or 88 bits. That is my that's what we need. Okay. Now, so 11 bytes is bigger than binary representation. Is that correct? How much binary representation of a number will require? Float number. So 8, because double precision requires 8 bytes for a real number. Okay. So 11 is more than 8. So a number is inaccurate. Also, we need to have more bytes typically. Okay. So that's a problem. So binary is a better representation. Binary is exact copy on the hard disk is saved. And when I read it, exact copy is loaded back from hard disk onto the RAM. So this is the preferred model. And so for numbers, it's preferred that you store as binary. Okay, numerical computing, I want to say exact number and we pull it back when I need it. Okay, so this is offered in Python in different ways, which I will cover a bit later. And so the access mode argument is exactly the same as this, except I need to put a B after this argument. So we are RB, WB, AB, and RB plus. Okay.